Hello there, welcome to another episode of our main topic, which is work, energy, and power. Today, we'll be taking power. So, in case you've made our last two videos on energy and work, I advise you watch them before you watch this to gain more insight on what you're about to do. So, let's begin. So, power is the rate of doing work. So, the rate here denotes time. So, the time taken to do a specific work is what we call power, or the time taken for energy to be dissipated is what we call power. As I said in our previous video, energy really relates to what work done. They even have the same unit, which is joules. They really relate. So the rate of dissipation of energy or the rate of doing work, they are the same. That is what we call what they all come together to what we call what power. So okay, so power is also measured in watts. So the SI unit of power is watt, also denoted by a capital W. So power can be mathematically expressed as work done over time, or force times what velocity. So how did we move from work done over time to force times velocity? We know that what work done is equal to what force times what distance. Force times distance. So if it's force times distance, then our power 2 is what over time. So all over what our time taken. But we know that velocity is equal to what? Distance over time. That means in place of this distance over time, we can put velocity there, which is going to be F, which is our force times our velocity. So that's how we came to get this simplified version of what? A power formula. So it is force times what our velocity. Okay. So in case you see on a light bulb that it is 100 watt light bulb, it means that what it uses 100 joules of energy every second. So for every second it uses 100 joules of energy, or it dissipates 100 joules of energy every second. So if it's 50, it dissipates 50 joules of energy every second. So that's what it means. So let's take our first example. Students A and students B both carry identical boxes up the same stairs. Student A takes 10 seconds and student B takes 5 seconds. Who has more power? So as you can see, student A takes 10 seconds, student B takes 5 seconds. They they have done the same work because they carried the same box through the same distance up the stairs. So that means work done for A is equal to work done for what B. But here, what differs is our time. So who do you think has more power? So I think student B has more power because it's like you are taking a box somewhere and I took 5 seconds and you took 10 seconds. That means I have more power than you. So mathematically it can be expressed as what? P is equal to W over T, which is power equals what? Work done over time taken. So as you can see, power is inversely proportional to time. So that means as power is what? Increasing, time will what? Decrease, and work done will what? Increase. So that means power is directly proportional to what? Work done, but inversely proportional to what? Our time. So you should put this in your head because students B took less time to do it. So if it took less time, that means what? He or she what has more power because the time is less. He or she has more power. So if student B took less time, he or she has more power. So this is the mathematical way, and using normal analysis, you can see that it's like you holding carrying a metal. We are all carrying a metal, and I took 2 seconds to take the metal. That means I have more strength, I have more power than you taking 10 seconds. Okay, so let's take our next example. A pump is used to lift 500 kilograms of water to a height of 20 meters in 10 seconds. Calculate the power of the pump in watts. Let's assume our gravity is 9.81 meters per second square. Okay, so if you think you can solve it, you can pause the video and give it a try. So we know that power equals work done over time. So I think this formula is applicable in every power question. So you should put this in your head. But here we weren't giving work done. We were giving mass, we were giving distance, and we were giving time and acceleration. What can we do? But we know that work done is equal to what? Force times distance, which is F times S. But here too, we're giving force. But we know that what our force is equal to mass times our acceleration due to gravity. So force equals mass times acceleration due to gravity. So in place of our force, we can put acceleration due to gravity, and our mass is what 500, which is this, and our gravity is 9.81. So this is it. This is our force. This is our force. So 500 times our 9.81 times our distance, which was given to us as what 20 meters, 20 all over our time, which is 10. Now you're going to get your power to what 9810 watts. So I think this the answer 9810 watts. So this is how you apply. So sometimes you might not be given like the direct. Sometimes you might be given work done. Sometimes you might not be given. So when you are not given the work done, you have to break the formulas into bits. So another formula for power can be mass times gravity times distance all over time, because mass times gravity times distance is the same as what work done, and mass times gravity is the same as force. So it's up to you to break them down and apply all what I've said. So this is FC Star Creations and Technologies. So you can subscribe, like, share, and comment.